Hello. All right, let's go. So yeah, that's something I'm toying with, so that way we could potentially get a lot more practice in anyway. So it might work out better for everyone that way. But then we'll talk about that in time. Just talk to yourselves, talk amongst yourself, decide if that's something you'd like to do. Because I think, and then we can do that. Even if you guys want it to run a bit more than 3 hours, I'm happy to do that as well. If it's especially if it's in the morning, I could the people who aren't coming to Extension 1, you can just come and I just won't charge. I'll just drop the price to just be the one class, and then everyone can just show up to everything. That way I can make sure you do well on both papers, because I want to make sure everyone does well on everything. That's kind of important here. So anyway, we had a few people post a few questions. So how have you guys gone with your practice this week? Have you all put something up on the challenge? No one's used the challenge yet. Let me just go here. Did you guys all get how the challenge works, or let me just kind of put it up here for a second. So the challenge is here. Obviously I put a lot of time into that, so don't be counts, make sure you're actually competing. So I've only got a few people who have actually put anything up so far. Are you all, did I forget some of you guys? Are you all here? I think I've got you all right. Everyone sees their name? Yeah, cool. So have you guys started taking exams, or what's the situation? Are you just not putting the marks up, or? So you started but haven't put the marks up? Yeah. What's up with that? Why not?
Oh, I just forgot.
Okay, cool. So just every day as you're doing it, have you all got it on your wall somewhere, or yeah, all got it. So you guys are actually giving it a crack, right? So as you do them, just put them up. I do find compete at this, you're not going to regret it. You're going to do very, very well. So that should be that. So not too much to say there. But one thing I do get to do, sorry, I forgot. This is important. At the beginning of every lesson, what I do is I'll just ask you guys, what do you want to be on by next week? So I want everyone to sort of declare what you're going to do, how many you're planning to be on by next week. And we're going to do that at the beginning of every lesson. Just kind of like a mental out loud declaration, right? So Tyrus, you tell me, what are you going to be on by next week?
As in what mark I'm getting?
How many exams will you have had done by next week? The fuck?
For hopefully maybe 3.
What? Didn't he? Surely, anyway, 3 is good. So what I'd like you to do is give yourself an actual challenge here, something a bit hard. Could you hit 5? You have 5 up here by next week?
Yeah,
5, okay. Have 4? 4?
He's only for math or for every subject?
9, you said 9. So Blake said 9 in physics. This is across all your subjects.
Oh, so I'm not from this Kevin physics pass paper, is it?
That's up to you. I'm just saying, how many past papers do you reckon you're going to get up to by the end of the week?
Next week.
Why aren't you starting chem and physics?
Because I finished module 8 yet.
Like at school?
I revise mod 8.
Yeah, I need to revise it.
Okay, that's fine. I mean, just.
Probably for math, for 3.
So you reckon you'll be up to 3 or 4? This is across all your subjects, right? You put your English papers. Have you guys actually tried the form so you can go in there? By the way, one of the cool things about this is you can actually you can go to data here, and then you can go you can actually just you can group by view, so that you can make this filter view, and you can see all your own papers as well, right? If you just wanted to see just yours, you can do that, and it'll just show you yours. So it's really just a good way to track yourself, right? So it's it'll show you your own and all your marks and everything, and also the student progress will show you how far you are, and this shows you you can isolate yourself here too. You can just click on whoever you are, and you can see how many you've done across time. So you can see if you're slowing down or speeding up. So it's pretty good. I made a whole little system for you here. Just do the papers and get some feedback as you go. You'll see that you'll get a lot better quite quickly. So what we want to do here, so we're going to start here, is I'm going to look at the questions that you guys have posted first, and then we can sort of continue on with anything that you guys were sort of struggling with before. So let's see. We're going to look at Christian. You can hear everything, right? I don't know if you can, but it's fine. Okay. So there are a few questions here. So I saw only really Christian posted questions during the week. So you guys, I'm assuming, didn't do that many papers this week or something? Yeah? Okay, cool. Let's get on with these ones then. So problems here. We started with if k is an integer, was k is less than greater than 3 and k minus 1, k plus 1 is less than k squared. Show that this is all going to be true. Okay, so these are all just random questions I think you got online, and they're just your standard ones. Now, how were you guys taught to do inequalities? How do you guys generally approach inequality proofs? What's your general approach? Does everyone see, by the way, why this one is true? Just starting off, like, can everyone see? Tell me clearly why k minus 1, k plus 1 is less than k squared. Can everyone explain that? Why is that true?
It's k squared minus 1.
Yeah, because if you expanded the left-hand side, you're going to get k squared minus 1, and obviously that's less than k squared, right? And strictly less than, right? Can't be greater than or equal to. So k is a positive integer, so whether it was negative or positive, this should always be true. But anyway, can you show that that is true? So what's your general approach for these kinds of problems? What do you usually do? Anybody have any ideas? Or not really? So when I'm approaching these, so I'm just going to like single people out here, just because I want to see if like people are just scared to talk or something. So no, that's George. I haven't asked you any questions. Sorry, George. What's your usual approach? What do you usually do?
For inequality, you start with one side and then you compare it to the other.
Yeah. So I generally don't do that. So you start on the left and try to get it to the right, do you?
Get it to the left and then get it in a form where you can compare it to the right.
Okay, fair enough. So my usual way of doing it is actually to just like subtract the right and prove that it's greater than 0. That's
Bruno told us you can't do that.
why did she tell you you can't do that?
Telling us you can't do left hand side minus right hand side. You have to start with one side.
Well, if you prove left hand side minus right hand side and then you use that to prove the thing, that should be fine, no?
She's always telling us you won't get marks for that.
Huh? Since when? Okay.
She's saying like she marks HSC and they don't accept it.
Okay, that's
I don't know how trustworthy.
I don't believe that. That seems wrong. But I mean, like, yeah, that's fine. Because if you prove that left is greater than right, for example, that's the same thing as proving that left minus right is greater than 0. That's exactly the same thing, right? If you prove that, and then maybe if you didn't make the step saying, because if you prove this and then you use that to then show that, then it should be okay. But yeah, okay. Then if we want to do it from left go to right, we can do that too. It shouldn't be a problem. But generally speaking, that's usually my approach, right? So I'm surprised though, because that's been we've been doing that for years and years, so I haven't had a problem. So I don't.
My teacher, the one that we do school now with, he's what's called HC marker, and that's the first way for us to do it.
To subtract it. Yeah.
That's the first way.
That sounds right to me. Yeah. Like. Yeah, that sounds more on par, because that's literally silly. Proving that left is greater than right is equivalent to proving that left minus right is greater than 0. That's exactly the same thing. So that's kind of silly. But that's generally what I will do. But yeah, I'm gonna trust your dude is like literally he wrote the textbook, so I'm gonna trust him.
Trust Mrs. Bruno.
Huh?
If you listen to Mrs. Bruno, you do worse than me. Trust me.
That's generally don't listen to her. Generally is good advice. Yeah, but anyway, that's fine. So let's start on the left hand side. So if you want to prove this anyway, if you want to prove that that's greater than k cubed, you can. This one's a pretty easy one anyway, but you can see that you have a difference of 2 squares on those guys, right? So you should be able to rewrite this as k squared outside of k outside of k squared minus 1, right? K squared minus 1. You have to prove that's greater than or equal to 1 on k cubed, right? So here. You start with, first you can say k squared minus 1. That's going to be less than k outside of k squared. You all agree with that? That's like obviously true. And so then if you flip both sides, you're gonna have to flip the sign. So k squared minus 1 is going to be greater than 1 on k cubed. So that's easy peasy done. Is that cool? So that's part 1 done. Part 2, what are we going to do? Let's try to be clever here and try to think about what we might go about doing here. So given that Sn is this whole thing, use partial fractions from the previous part to prove that Sn is less than or equal to 1 on 12. How are we going to do that? Anybody have any ideas there? I don't have any thoughts. Like I just I'm gonna single people out just purely because you guys don't talk much, so I'm gonna get you guys to talk. So Lauren, help me out. What are you thinking? What do you immediately see when you have a look at this? Yeah, that sounds like a good idea, right? So if I'm gonna, that's a good start. So we're gonna say, okay, the sum from 3 to n, 1 on k cubed. Okay, that's less than, for sure, the sum from 3 to n of 1 on k minus 1, k plus 1, right? Okie dokie, we all happy with that? So now what we really need to prove is that this somehow evaluates to 12, right? 1 on 12. How are we going to do that? What are we going to do there? So we need to prove that that whole right-hand side thing is equal to 1 on 12. What are we going to do? So we're required to prove that basically the sum, the right-hand side, is equal to 12. Any ideas? So they're saying use partial fractions from the previous part. How does that help you? What does that mean? Partial fractions from the previous part. What do you reckon?
Like split 1 k times k squared minus 1 into separate fractions.
That's right. Now, have you guys all heard of the idea of a telescoping sum? Have you guys heard of the telescoping sum before? Have you heard that term before? You have? Do you want to tell us what it is? Okay, that's fine. So, for example, if I want to add together a whole bunch of terms, right? Whenever you have, like, let's evaluate the term k equals 1 to 10 of, let's say, k and then k squared minus k plus 1 squared. That's called a telescoping sum. So it's when you have two terms subtracted from each other, right? So sequential terms, sequential subtracted terms. Fair enough? Subtracted terms. Why would this be helpful? Can everybody see why that would be helpful? What do you think this sum is going to be equal to? I just gave a simple example of a telescoping sum, but telescoping sum, you have two terms which can be expressed as a function that increases by 1. When you subtract them from each other, what's going to happen? Right?
So we cancel out.
Yeah, all the terms are going to cancel out. Let's write the first two just so you can see what's going to happen, right? Let's say put in 1, you're going to have 1 squared minus 2 squared. Yeah? And then you're going to have plus 2 squared minus 3 squared. You all see that? So this is called a telescoping sum. It's the idea that all the sequential terms go bye-bye. See that? So then the last term you're going to have is you're going to go up to 10. So you know everything is going to cross out until the last guy. So you go plus dot 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 dot. Last guy is going to be 11 squared. So the answer is just going to be 1 minus 11 squared. You all see that? So this is 1 minus 11 squared. This is generally going to be the case where this is generally going to be what you're going to want to set up every time you're going to evaluate something to come to a number. Every time a big sum like this, especially when it goes up to n, just comes out to a simple number, you need to prove that it's less than 1 on 12, right? So you're going to need to prove that it doesn't matter how many terms you add, it's always going to be, this whole thing should somehow fully cancel out to a single number. You all see that? So how are we going to do that? Let's see. We're going to use partial fractions on this. So let's break this up. So it should be a on k plus b on k minus 1 plus c on k plus 1 equals 1 on k minus 1, k plus 1. Everyone agrees with that? Yeah? So if I wanted to find a quickly, what's the quickest way to do that? How do you guys usually approach partial fractions? What's your usual approach here? So if I wanted to find a quickly, what would I do?
Sub k equals 0, the right answer.
Yeah, that's right. So if you sub k equals 0, but under the pretense that you destroy the k. You all see that? So if you get rid of the k, then you know a is going to be what? It's going to be minus 1 times plus 1, which is minus 1. So a is minus 1. And then b is? Did everyone understand how I did that? Anyone not get that? Yeah. So b, how do we approach b? What are we going to do here? So b, same thing. You're going to plug in 1 in this case, where you ignore this term. So if you plug in 1, you're going to get 1 on what? 1 on 2. So 1 on 2, so that's half. And then c, what do we get? If you sub in minus 1, ignoring this term, you're going to get minus 2, right? Minus half. And we can kind of see our telescoping sum showing up there, right? So the point is that the right-hand side is equal to the sum from 3 to n of, now, minus 1 on k. Yes? Oh, sorry, yeah, minus 1 on k, plus a half of 1 on k, basically k minus 1. Yep. And then minus a half of k plus 1. Everyone agrees with that, hopefully, or not really? What do we think? Yeah? So then what are we going to do is we're going to just sub all of these in and just try to see what happens. Shall we? Okay, so let's just sub in a few numbers and just try to make some sense of it. So we're going to first sub in 3, so you're going to get minus 1 on 3. C is positive half, is it? Did I screw that up? So if you plug in C, you're plugging in minus 1. Yep. And so if you plug in minus 1, where are we? So we're going to ignore this term. Yeah, I think you're right, actually. So because you're going to get minus 2 here and then minus 1 here, so you're going to get positive half. You're right. So that's it there. So positive half there, positive half there. That's even better. That works even nicer for me. Why? Because now every two of them can sort of join together. Can you all see that? So that's actually even better. So minus 1 on 3. And then what have we got here? Plus, I'm going to write half of 1 on 2. Yeah? Plus half of 1 on 4. Everyone sees that? And then the next term is what? Minus 1 on 4. Yeah? Plus half of, what is it? Half of, whoops, 1 on 3, and then half of 1 on 5, okay? So, do we see any patterns here that we might be able to help ourselves out with, or not really? What have I got here? So I got the half of 1. We could it probably would help to write in another term, so we at least add in a third term because we have 3 of them here. So let's just keep going. So I'm gonna go. The next one would be minus 1 on 5 plus a half of 1 on 4. Yeah. Plus a half of 1 on 6. Everyone agrees with that? Now look at this. This is cool. So the half of 1 on 4 and the half of 1 on 4 cancels out with the 1 on 4. Cool? So which terms stick around? Right? Then you've also got the half of 1 on 5. So I'm going to do one more term just to really show you what's going to go down here. Yep. Hey, how you guys going? You waiting for Marianne?
Yeah.
Oh, she think she might have. Did you get a message from her?
Yeah.
Oh, okay. Just.
yeah, she said today, 4:30.
Okay. Well, just ask her. Yeah, just see what's going on. That's fine. No worries. Okay. So you guys all got this half of 1 on 6, and then what are we gonna do here? Next term is help me with the next term. Just make sure you guys are all following. Tyrese, give me the next term, would you?
Wait, why is that half on 6?
Because it's the k plus 1. So which term is this? This is the k equals 5 term. This whole thing is the k equals 5 term. Yep.
Okay.
So what's?
1 on 6
Mm-hmm.
plus half of 1 on 5
Mm-hmm.
plus half of 1 on 7.
Mm-hmm. All right. So what's going on here? Same deal, right? The 1 on 5 goes bye-bye with who? With this one, and this one, don't they? So which terms are sticking around? Which terms are actually surviving this whole massacre? Which terms stay? So what you all understand that eventually in the limit so there's going to be a whole bunch of terms. The last term that's going to stick around is going to be this term over here, which is going to be 1 on n. Do you get that? So all the terms are going to be killed off in this massacre. The only terms that are staying around are minus 1 on 3 plus 1 on 4. Yeah? Minus 1 on 3 plus 1 on 4. And then plus all the other terms died. And then the last term is 1 on n. Yeah? Where n is going to be, minus 1 on n. Where n is going to approach infinity. Is that cool? So here what we're kind of understanding is that 1 on n kind of approaches 0. What's wrong, Mary? Weren't you cancelling these classes?
No, just my one off.
Oh, okay. Just close the door if you can, yeah? So do you see that? So the only terms that survive are 1 on 4 minus 1 on 3. So what is 1 on 4 minus 1 on 3? Equals? Well, you're gonna have a minus 4 plus 3. So I got minus 1 on 12, didn't I? Did I get a minus 1 on 12? I think we're...
Well, what about the plus half 1 on 3?
What's this?
Doesn't cancel out.
Oh, it doesn't cancel out. Yeah, you're right. That actually stays along. So what does that do? So it's going to make it a 1 on 6, minus 1 on 6, right? Yep. Everyone agrees with that?
Half 1 and 2.
The half 1 on 2? I kept that. That's 1 on 4.
Half.
So this is the 1 on 4. This is the minus 1 on 3. And so all of this stays, but the last term is the plus half 1 on 3. So plus 1 on 6. Isn't that right? And this is just the 1 on 3. Minus 1 on 3. So if you just put that into your calculator, just because I can't be bothered, what do you get?
1 on 12.
Huh?
1 on 12.
Beautiful. Friggin' earth. Great, we did it. Everyone sees how that works? That's a quite a difficult problem, I have to say. That's a difficult problem. But do you all sort of see how we do that? So sort of step by step. So generally speaking, whenever you see something resolving to a whole number, I always like to ask the question, what do we learn here, right? So every time you see something resolving to a whole number, see how I knew immediately I was expecting things to cancel out? Right? So every time you see this, you're expecting a telescoping sum. And you'll see that as you practice, right? You're going to expect a telescoping sum. Does everybody understand what a telescoping sum is now that we saw this example, right? I didn't even really look at this problem beforehand, but I kind of just knew that that's kind of what we were going to do. All right, so what's next? So we're looking at the P and Q. I might jump between the topics, so we're not doing all of the same topic, right? So I might just jump between all the different topics that we have questions on. So let me do that. Are there anything in particular you guys wanted to look at today specifically that you're feeling a little bit like needs a bit of attention recently? Or do you guys feel like any specific topic that you wanted me to add a question or two in? I mean, there was obviously going to be a bit more on complex numbers added on today. We because that's been obviously the main one. Oh, what the hell happened? Sorry, one sec. Where's the phone? Sorry, just completely shut itself. One sec. Have you guys been like revising the topics that you're struggling with at all, or not? Like, what's your sort of study looked like over the last week? Maybe is the good question to ask for the time being. Like, have you guys just been chilling, kind of? Seems like, yeah, after the trials, you're just like, fuck, need to decompress. You guys have like parties or anything this week?
One's a bit of a party, I mean.
Yeah. You doing much? Oh yeah. Always the birthday parties right after the trials are always like fun. Those are always the funnest ones because like people are just like chill for like that week, and then after it's like everyone just sort of gives in. It's like, okay, let's try this one then. So diagram shows a triangle OAB where M is the midpoint of. Oh, it's all good. So triangle shows OAB where M is the midpoint of AB. Let OA be 7A. Fair enough. And let OB be 5B. Sure. C is the point such that OC to CA, so OC to CA is 5 to 1. Okay, so OC to CA is 5 to 1. Let's immediately, like, not even waste any time here. What is OC as a vector? If OC to CA, wait, did I do that right? OC to CA is 6 to 1, my bad. So it's 6 to 1, right? What does that mean that this vector immediately is? The vector from here to here is? 6a, easy peasy, right? So just write that down immediately so you're not wasting any time. D is the point such that OB to BD is 5 to 1. Yeah? So that means BD is? BD is what? So again, OB to BD is 5 to 1. So Blake, what do you reckon BD is? OB to BD is 5 to 1. So that means BD is?
B.
Just B. Everyone's cool with that? Anyone have any problems with that? Grande. So it's asking you to show that C, M, and D are collinear. We all happy with that? Okay, how do you show that things are collinear in general?
Like scalar multiples of each other.
Yeah, so show that they are scalar multiples of each other. So showing that things are collinear, showing collinearity. Okay, you have two options. Yep, so you got a vector A, and you got a vector B, and you want to show that they're collinear to each other, right? You have two options. The first is to show that B is equal to some constant times A. That's one possibility. What's the other possibility? You know, before I start, I always like to ask these questions, right? So B is equal to some constant times A. What's the other possibility? There's another one. Anyone know the other one? Okay, so the other one is that you can show that A dot B is equal to what?
1.
No. Length of A times the length of B. Yes? Because the cosine theta is equal to 0. Yeah, so either one of those approaches is good. It doesn't matter which one you do. You should be able to prove it with both. Okay, so you want to show that C, M, and D are collinear. So, all right, so we're going to try to express M. We want to express CM and CD. That's going to be our, our goal. We'll try doing it your way, right? We'll try doing it the way you said. So the way we're going to try to prove it is we're required to prove that. What are we required to prove? I want to make sure that you guys can all write this down yourselves so that there's no dramas at all. We do know that M is the midpoint of AB, and that's important. We're definitely going to need to use that. So M is the midpoint of AB is the only one we know. We only know that it's the midpoint of AB, right? We don't know anything about it being the midpoint of CD. We don't know that. It hasn't said that, right? So we just write that down for yourself so you realize it and you don't accidentally use it. We don't know that M is mid of CD, right? We don't know that. So just keep that in mind. And so what are we required to prove that? If we want to prove that C, M, and D are collinear, we can write that as Cm equals some constant times CD. Everyone's happy with that? Okay, let's do that. We can do that, no problem, right? What do we do? So it's 3 marks here. So how do we want to start? How do you guys generally start here? So Chanel, I haven't asked you any. Go for it. What do you think? What's your best guess? Yeah, good plan. Okay, so how do we do that? By the way, there's a really nice way to help visualize a lot of this because I don't want you wasting a heap of time. When you think of the subtraction of 2 vectors, A minus B, what does that look like? Right? How do you, if I drew a vector A and a vector B for you like this, what does A minus B look like? Goes from where to where?
From B to A.
Yeah, A minus B is backwards along B, forwards along A, right? So it's like backwards, start here, go backwards along B, forwards along A. So A minus B is just the vector that points from here to here. Are we all on the same page here? So that's what we're looking for. So CM and D are collinear. What do we do with that? So, all right, CM is equal to K times CD. So CM, well, let's write out CM like you said. So what is CM equal to? Can anyone help me with that? We do know that it's the midpoint. So what do we do?
CA plus half AB.
Yeah, so it's CA, which we know is just the same thing as 7. We're going to write everything in terms of A and B, right? So we know that that's just 7A. We just, if you have vectors like that, just immediately write them in terms of those vectors, right? Those are your basis vectors. So it's equal to 7A plus 1/2 of what did you say?
Wait, no, I don't think it's 7A, I think just A.
So you said CM?
Yeah.
So 6A, sorry, my bad.
Like, isn't it just A? 'Cause,
You said CM, right?
yeah, CM.
CM,
Equals CA plus AM.
you said it's CA plus AM.
Yeah.
Oh, CA plus AM is what you did. Okay, cool. I was going to go like backwards this way. And, yeah, that's fine. So you're going to do CA plus AM? Yeah, that's fine. We can do that too. So you just said A plus AM. What did you say AM was?
Half AB.
Yeah, so you got this one here and this one here, yeah? So what's this vector equal to?
Minus 7A plus 5B.
Yeah, so backwards along 7A. So it's 5B minus 7A. Got it? Plus half of 5B minus 7A. Everyone's in agreement? That's what CM is? Yeah? So, okay, so then you also want to write CD, yes? What's CD equal to? Yep. Just push hard. Yep, just push. There you go. Oh, you're here. Hello. Come in. Sorry. Yeah, just sit down. We're just doing some problems. We have big problems always. Big problems. Okay, so we are just doing this vector problem for now. So CM is equal to that. CD, how do we write CD? So Lauren, help me out. CD, what do we do? So I would be, yeah, I'd be doing, well, yeah, you're saying CO plus, what is it? OD. So that's going to be, again, give it to me in terms of the A and B. Yep. Minus 6A plus 6B. Everyone's happy with that? And then what you do is you want to solve for K. So just show that K is the same for both vectors. So just plug those both in. So it's going to be A plus 1/2, 5 on 2, B minus 7 on 2A equals some constant minus 6AK plus 6BK. Everyone's happy with that? All right, so if these two equations are going to be the same, you've got A minus 7 on 2. Brain doesn't like that, so 2 on 2, minus 5 on 2. Minus 5 on 2, A plus 5 on 2, B equals, looks pretty good to me, right? You all see that? So you've got minus 6A plus 6B times K. Yeah? Are these exactly the same? Yeah. You can just, can you find K is the question I would ask, right? So if you equate the coefficients, 5 on 2 equals 6K. Yep. So therefore K equals 5 on 12. Everyone agrees with that? So it's not the midpoint of the other side. That's interesting. So it's not even the midpoint of the other side. By the way, when you want to test this kind of thing, obviously you, how would we make a Desmos of this quickly? Do you guys know how to, like, if we wanted to make a quick Desmos of this, just so that you guys can test this out. Sometimes it's good when you're practicing. Obviously, for this example, it's not that hard, but we'll do it anyway. So if I wanted to do, I'm going to just define an A to be whatever the hell I like. It could be the 0.34, let's say. By the way, Desmos geometry kind of works a little bit better for this. So if you go to Desmos and hit the geometry button, you can use this. You can even type that. So you can just type the point A is equal to, I don't know, 2, 4, whatever it is. And B is equal to the 0.51, right? So I've got these two over here. And then I could do the origin as the 0.00. So I could just show the vector, you just type vector, and then O to A. Do you guys know that you can do this as well? Vector O to B. And then you can just use that to sort of draw in all the points that you're interested in. So the point C is 7A. So we know that the point C is equal to 6A, sorry, 6A. So it's going to be up there. See that? And then just label that as a point C. Can you all see that? No, that's what it said there. The point A, I'm just copying this from the diagram, is 7A. Yeah. My head is in the way. Okay. So point A is 7A. The point B is 5B. The point D is 6B. You all see how I'm doing that? And then this is my little thing. This is my little picture. Yeah. And so you've got these 2 points here. M we said was equal to the midpoint of AD. So you said M. You could just find M, but it's the same thing as 7A. M is 7A plus 5B minus half of 5B minus 7A. Okay, and that's your midpoint right there. Can you all see it? So the funny thing is it's telling us that it's not actually the midpoint of the other side. Do you all see that? And it kind of looks like it isn't. See? It doesn't look like it's exactly halfway. You all see it? So it's the midpoint of one side, but it's not the midpoint of the other side. So it's kind of useful to see that. You can also good thing about Desmos geometry is you can actually just join all the points as well. So you can see it directly. It's pretty cool, right? So you can kind of see that this isn't the midpoint. Very clear. Just nice for this kind of application. So you can kind of see, you can make an interactive picture of it pretty easily. Okay. So if ever you're kind of stuck or you're like, oh, I don't really get this, I want to visualize it. It's something you can usually make an interactive for in a few seconds. So it's not something you want to worry about too much. Okay. So that's done. Let's pick up another one. So mathematical induction. It's later. So we're doing extension 1 at I said 7, yeah. So we have the hour break and then yeah. So I just needed to swap it for today. So Blake, you don't do extension 1, that's right. So prove this by mathematical induction for integers. Oh, is it all good? Oh, it wasn't about the problem? Oh, you're good then, no problem. So prove that d on dfxn is this by mathematical induction. Okay, so we're saying this, now this one is actually a pretty straightforward problem. This is asking you to just prove the Taylor series. You guys all done the Taylor series before? You've seen the Taylor series before? This is literally just asking you to prove the equation from the Taylor series. This is just quite literally the Taylor series equation. So it's just asking you, can you please prove it? Prove the nth derivative is equal to that. Okay, so this one is just honestly something you can do by, just by assuming it. Like it's pretty straightforward. So I'm going to skip the k equals 1 case. I think you all know how to do that. Let's just go straight to the k equals k case. So the dk with respect to k of 1 on x is equal to negative 1 to the power of k times k factorial all over x to the power of k plus 1. All right, and then for the k plus 1 case, I just go ahead and repeat that, but just swap all the k's for k plus 1s. Right? Now there's only really one insight that you have to have here, and if you have that insight, then everything is golden here. So you're required to prove this. What do we do? I just want to see if anyone sort of knows what to do here.
Chain rule on the n equals k plus 1 case to bring them down.
The chain rule on the k plus 1 case?
Like the k plus 1 is d on dx of like the left hand side of the bottom line.
Yep.
Is the derivative of the top.
Yeah,
left hand.
exactly. That's right. So just basically apply the derivative to both sides of the kth case. That's basically exactly right. Yeah. So if you just apply the derivative to both sides, right? So differentiate both sides. It's very straightforward. That'll just take you to that. Okay. We just need to prove that the right hand side is equal to the right hand side. So from the left hand side to the left hand side, that's easy. But from the right hand side, you need to prove it. Okay. That's what we're trying to do. So you just need to prove that we're basically required to prove. Copy these two, that these are the same. Can everybody see that? Rightio? Alright, let's do that. So if we differentiate the left-hand side, what are we going to see? So I'm going to start with the left-hand side. I'm going to get, well, the negative 1 to the k, that's a constant, right? So everything that's a constant, eat it out of there. Is that cool? So negative 1 to the k, that's a constant. K factorial is a constant as well. But you're just trying to differentiate x to the power of k plus x to the power of negative k, negative 1. Yeah? That's effectively what you're trying to differentiate, yeah? So left-hand side equals that. And so then it equals negative 1 to the k times k factorial. And then if you differentiate that, you're going to get negative k, negative 2. Yeah? What's wrong? Oh, did he lose? Oh, we cannot hear you, Christian.
Hello?
Oh, sorry. It's because I was completely muted. Sorry,
Oh
Christian.
my days.
Sorry. Yeah.
I just had a question for the previous one.
Yep. Tell me.
To prove something's collinear, don't you have to prove that they both go through M? Like you can't just prove that one is just a scalar multiple of the other.
You have to prove
'Cause
what?
if
Sorry.
it's just going, don't you have to prove that it goes through M? Because what if it's going in like the opposite direction? That could still be like a scalar multiple.
Well, we did, right? It would have to go through M because CM is here and then CD is here, so it would have to go through M because if CD goes through M, then if CM goes through M, then CD has to go through M if they're scalar multiples of each other.
But what if M was like on the other side? So it was like flipped. So it was away. It was not in between C and D.
Then it'd still be collinear. Collinear just means that they lie on the same line.
Oh, okay.
Yeah, so it doesn't actually matter. Even if effectively that would just happen if the k value was a value greater than 1, then M would be over here.
Okay, yeah, okay,
Yeah.
no, that makes sense.
So
Alright,
as
thank
long as
you.
you prove this, you're sort of golden. You're actually good. Okay.
Yeah.
So
Alright.
continuing on. Sorry, sorry about that. Yeah, but I can hear you now, so you can just speak up anytime now. All right. So
Alright, thank you.
no worries. So now this is going to become x to the power of this, right? And I'm going to rewrite this as negative k plus 2. Everyone's on the same page there?
Maybe k plus 1.
K plus 1. Sorry. Yeah. we're not integrating here. Yep, everyone cool with that? So this negative can be just written as -1. So we're just going to rewrite that like that, and then we're done. Right? So it's -1 to the power of k plus 1, because there's a bunch of those. And then k factorial times k plus 1 is just k plus 1 factorial. And this is just 1 over x to the k plus 2. What's wrong?
There's no exam. CSA 20.
This exact one?
Yeah.
Yeah, I believe that. Yeah. But did you all get this one? Oh, you didn't get it? So it's a very, very simple question, I think, right? Do you find it hard or?
It took me 15 minutes to remember that rule about the derivative stuff.
Oh, that the derivative is.
Like, I knew how to do it, but then I just blanked. Like I knew what I had to do, but
So you're saying it took you a while to remember.
CSA 20. Did you know that?
I think yeah.
So
We have the Gaussian thing.
Yeah, but no one knew how to do that.
I got my mark
What did you get?
74.
So, no?
it's not bad, man.
I don't know, that exam was.
So this is the rule that you forgot, Tyrese?
yeah. Like, I remembered it during the exam, but like it took me 15 minutes just staring at it.
But when you're saying you remembered it, why did you have to remember that? Like
No,
I'm
no,
just.
not remember it, but like I knew the process and
Right.
I knew how to do that, but I just like I completely blanked. Like I could not write that down.
So when you get stuck here, let's sort of diagnose here what went wrong, right? That's more important than just showing you what to do. So what went wrong for you? Why did you get this wrong? Let's sort of think about
I
that.
finished it, but
No, I believe that, but you said it took you like 15 minutes,
Yeah.
right? So my question is even that, like that's not ideal either, right? So the question is like what went wrong? And you said you guys didn't even get it, right? So what went wrong for you based on what we just did? What step sort of fucked with you here?
I did all the other stuff, but I didn't know how to differentiate k factorial.
Oh, okay, so that's important. So again, this is important. What's wrong? So if I've got, let's suppose that I'm differentiating something with respect to a. This is actually a very, very important point here. So if I've got some function of b multiplied by some other function of a, okay, what's the derivative going to equal? Yeah, let's say they're different functions as well, right? So this is kind of where, yeah, every time you fuck up something like this, you absolutely have to like diagnose and figure out what went wrong, okay? It's very, very important. Now, let's be completely stupid about this, and when you're multiplying two things like this and you differentiate them, what's going to happen? What are you usually going to need to use?
Product rule.
Usually the product rule. Everyone agrees with that? So we're going to have the derivative of f of b with respect to a multiplied by g of a, yes? Plus the f of b times the derivative of g of a. Everyone agrees with that? Okay, now here's where it gets funky, right? What's this equal to? Zero. Why 0?
You differentiate a constant.
Yeah, as far as a is concerned, it's a constant relative to b. So let me give you an example. This is where, now sometimes when I write it in that dense notation, it's confusing to people, but let me show you that this isn't confusing. Let's give you an example here. D on dx of, let's say, 3a plus 4 multiplied by x squared plus 1. Okay, this follows exactly what I said. This is a function of one variable a, and this is a function of different variable x. Everyone happy with that? It's exactly the same problem. So if I differentiate this, what am I going to see? Well, again, using the product rule, I go d on dx of 3a plus 4 multiplied by x squared plus 1 plus 3a plus 4 multiplied by the derivative of x squared plus 1. You all cool with that? Now, okay, we'll talk about this. What's this equal to? What's this derivative equal to? Has to be 0, doesn't it, right? If there's two cases. If a is a function of x, then not 0, okay? Which is the case when you're doing optimization problems. When you're dealing with optimization problems, the a may be a function of x, and so you might have a relationship between the two of them. Is that fair? Then you need to use implicit differentiation, right? Derivative. Does everyone see that? Right? But else, 0. Do you all kind of see that? So that means this whole thing goes bye-bye, and then therefore this is just the answer, which just basically means you can take this outside of the derivative. Can you all see that?
What's the implicit differentiation and optimization? Like, is that in the syllabus?
Yeah. So for example, if I asked you to, okay, so you guys are all on the same page of me here. So this is why you notice every time we get a problem and you get stuck, I'm going to take a few steps back and fill in the gaps. That's what we're always going to do, right? So it's very, very important to you to communicate to me where you're stuck so we can fill in all these gaps. So what is implicit differentiation? Very good question. Let's suppose I asked you to find the tangent to a circle. Find the tangent to, let's say, x squared minus x squared plus y squared equals 9 at x y equals 3 4. Yep. Wait, that's not going to work. 3 times 3 is 9. 3 times, usually it'd be, let me just make that 25 because I'm a lazy fuck. Okay, is everyone cool with that? So that point is on the circle. Okay, how do we do it? Everyone understands the problem I'm asking. No one's confused by it. So I've got my curve here. So just, this is really, it's every time you screw something up, it's because there's something you didn't understand. Always assume that, and then always try to patch in the gaps. And then obviously I can be pretty efficient at patching those gaps for you, but you just have to like tell me where they are. So you all see this here? So I know for a fact that the point 3 4 is on the circle. I knew that, but I'm looking for the gradient of the tangent. How do we do that? How do we solve that problem? What's the way? What do you usually do to find the equation of the tangent? So just looking at the picture, I'm gonna ask somebody at random if no one volunteers themselves. So ready to fuck up, cunts. Mariano, my man, how you doing? Let's go.
You usually differentiate.
How do you do it? Yes, you differentiate, but like how?
So you differentiate, sub in point, sub in the specific x value to get the gradient, and then just make and then sub that.
Tell me step by step. Like let's do it step by step. The way you do it, your way. Let's say Mariano's way, right? Your way. Tell me what to do, like step by step. Seems like an easy problem, so tell me, what do you do? So you said find the point, and I've given it to you, it's 3 4. What do I do with it?
Well, you'd sub the 3 into the derivative function.
What's the derivative function? How do I find that?
Maybe rearrange for y. And then
Okay, so Mariano's way is make y the subject. Make y the subject, yes?
yeah.
Is that all of your way? Is that what you would all do? Does anyone have an alternative? Is there an alternative? Okay, well, okay, we're kind of screwed though, if that's your way of doing it. Why? Because, okay, try this. All right, now that's mean. I'm being very mean to you, aren't I? Let's do y e to the x equals, let's say ln x plus y. That's easy enough, isn't it? Make y the subject for me now. Good luck.
You can't.
GG, brother, you're screwed. What now? Does that mean you can't find it?
No.
So looking at this problem, so same problem, y e to the power of x equals ln x plus y. Okay, perfectly defined graph. Yeah, and let's say that I wanted the derivative up here somewhere. I'll just allow myself to come here. Come on, head. Here. Let's say I wanted the gradient right there. Perfectly defined problem. Can you all see why making x the subject or y the subject is basically impossible here? Can you all see that cannot be solved for x or cannot be solved for y? So what do I do in that case? Am I just screwed?
You need to rearrange from dy on here.
Yeah, that's right. I want to find dy on dx. So I'm not screwed at all. I'm perfectly okay to do this. So the way you would usually do is make y the subject and then solve for, right? Oh, bless you. And then differentiate, right? Differentiate. My way is to just solve the problem directly. Why the hell would you do that? That's silly, right? Just get straight to it. Differentiate both sides with respect to x. X squared plus y squared equals the derivative of 25. Differentiate both sides, no problem. And it doesn't really matter what you're differentiating with respect to. It's not actually important, right? Using the superposition rule. Everyone remember the superposition rule? So breaking up each term one by one. Do you all agree that this is valid? The right-hand side is obviously 0. Yeah? And so then the derivative of this first term is easy. What's that? Just 2x. But the problem with this term is that you can't differentiate it. You're like, oh, well, it's in terms of x. I'm screwed. What do I do?
You d on dy times dy on dx?
I could, but let's be explicit about that. I'm going to multiply by dy on dy. Everyone agrees with that? Using this thing called the chain rule. I'm going to use the chain rule, which basically means to multiply by dy and dy, which swaps those two for me. And then what I'm ending up with is dy on dx multiplied by d on dy of y squared. Of course I'm allowed to do that because these are infinitesimals. They are allowed to just cross out, yes? No problems. And it's all equals 0. So what now? 2x plus dy on dx, which is what I'm looking for. I'm trying to make dy on dx the subject. What's the derivative of y? Y squared. 2y. Yeah, that all equals 0. So dy on dx equals negative y on x. Grand. Do you all see that? So what do I get as the derivative? Dy on dx equals, according to the point that I gave you, negative 4 on 3. Everyone sees that? Yeah? Let's try it Mariano's way. Let's see if that's the case. Doing Mariano's way, we would say y equals the square root of 25 minus x squared. Yes? Then dy on dx equals 1 on square root of 25 minus x squared with a 2 in front, and then we go minus 2x. Yeah? Lots of missions, but dy on dx. Now let's pay attention here. Do you notice that this is just the hypotenuse of a triangle somehow? You'll notice that that's just the hypotenuse of some triangle, obviously, right? Looking very carefully what the hell is going on here. There's the tangent that I'm talking about. There's actually the triangle right there, you see? And we're just finding y on x. Here's the x, here's the y. Yeah? Or let's really be very explicit about this. Let me show you exactly what the hell just happened. Because sometimes it's nice to really see it, like really properly see it, right? You've got x, you've got y. Everyone agrees with that? If this angle is theta, and if I drew a tangent that's perpendicular, what do we know about circles? The tangent's perpendicular, isn't it? So then what I could do is I could just draw this triangle. You just draw this triangle over here, yeah? And do you all agree that that would kind of be y and that would be x? Yeah? Do you see that? Like this triangle and this triangle are similar to each other? Yep. So if that's going to be the case, then the gradient is going to be rise x on y. Right? Well, y on x in that case, right? The rise over the run. Did we solve that right? I actually made that wrong. It's minus y on x, isn't it? So minus x on y. See, like the geometry corrected it for me. Nice. Okay, cool. So minus x on y. I was like, oh, that didn't work out. So minus x on y, so it's actually minus 3 on 4. Everyone agrees? And so do you kind of see that that's the rise is minus x, you're going down by x, and going run by y? Everyone sees it? So if that's going to be the case, then by this logic, plugging it all in, you get minus x was 3, all on the square root of 25 minus 9, which is, of course, just 4. Very cool. Do you all see how this works? This process I just came up with, which is just differentiate directly and use the chain rule everywhere, it's called implicit differentiation. You should absolutely know how to do that. Right? It's because sometimes I'm going to give you some hard derivatives to do, but if you the reason I teach implicit differentiation is so that you don't get stuck on this problem here, which like you said, Chanel, right? I don't know how to differentiate k factorial. Well, simple question I have to ask you then, right, how do you differentiate k factorial? Let's ask that question again. So you said I don't know how to differentiate k factorial with respect to x. Well, I can just multiply by dk on dk, can't I? I can always do that, and then I can always pull these guys, all right? I don't know how to differentiate this. Like this is a pain in the ass. I'll let you know that this is very hard to do. This requires this thing called the gamma function. Very ugly, right? But this right one I know how to do. That's easy. What's the derivative of k with respect to x? In other words, how does k change as I change x? It doesn't change. Do you kind of see that? As I change x, why would k change? I mean, k is just k is just the power that I'm using. It has nothing to do with x. K is how many times I've differentiated, x is how far I've moved left and right on the graph. Do you sort of see that? Those two things are completely independent. There's no relationship between them. This is a 0, so therefore the derivative of k factorial with respect to x is 0. Do you kind of see what I'm saying? Or in other words, the derivative of anything with respect to x, let's call it r e to the r cos p, right, is equal to 0, assuming r is not a function of x and p is not a function of x. Or if you like, r is equal to, r is equal to some constant that is not a function of x. I can just write it like that. R is not a function of x and p is not a function of x. That's probably the best way to write it. Do you all see that? Right? Basically, if as you change x, r doesn't change, the derivative is 0. That's where you went wrong here. Do you all see it? So that's the main thing to know. So in future, if you're screwing these questions up, the reason you're screwing them up is because you're not, you have to realize when things are constants. If things are constants, out of the derivative. Cool? Everyone's happy with that?
Sivan,
Yep.
for the circle, don't you have to take the plus or minus case when you're taking the square root?
Yeah, sure. You could take the plus or minus case. What's the difference between the plus and minus case going to be?
Wouldn't that change the gradient?
Well, it would, because you've got this top half and this bottom half. So this is another reason why, you see, that's what's going on there. Yeah. Whereas in the implicit case, you actually don't have that problem at all. This doesn't have that problem whatsoever. That's why this is actually the better way to differentiate almost every time. This actually doesn't accidentally throw a plus minus in there as an artifact of the fact that you took something that is not a function and you forced it to become a function. Do you kind of see that? So this is actually a worse way to do it. You all see what I'm saying? Because I gave you a point that I knew was in the top half, so I don't actually need the plus minus there. Do you all see what I'm saying? Cool. Answer your question? Christian, make sense?
Also.
Yeah.
Yeah, no, that makes sense. Also, for that rule that you put in the purple at top, are we were we supposed to know that?
Yes, absolutely.
Because I think I reckon if I knew that, I probably could have solved this question.
Yeah, but you did know that, right? The second derivative, let's think about it. The second derivative is equal to the derivative twice. That's what it is, right? Isn't it?
Oh, okay.
It's just, what is a second derivative at the end of the day? Someone asks you for a second derivative, it means differentiate twice. Yeah, so the 50th derivative is differentiate 50 times. Do you all kind of see that? So here's another reason you went wrong. Reason 2, right? Everyone happy with that? So those are the 2 reasons I think most people would have screwed up this problem. Great. Next problem. Let's look at the next one. Species of fish lives in a lagoon. Did you guys know this one? Was that also in your exam? Did you guys all get that right?
I think I did, but I don't know if it was real, except the way I did it.
Gotta love that. You gotta A, get the exam right, and B, have to contend with yeah.
She made me lose them off because I didn't write +0 as a constant.
Huh? Are you serious?
Yes, bro.
Legit, I chunked this lady. Legit, anyway, a species of fish lives in a lagoon. Each year, the fish population increases by a factor of r is greater than. Who did get this one right? Did you get it?
I don't remember.
Do you remember the question? Do you see the question?
I know the question, I just don't remember.
Okay. You just kind of remember it was there. It was you're at that point. You were so stressed out. You're like, fuck. I don't remember what the hell's going on here. All right, let's just do it together. That's fine. Did you get this one?
I haven't got my paper back, but I didn't attempt second part.
All right, let's do it. Let's make it happen. So a species of fish lives in a lagoon. This is from extension 1 or extension 2?
2.
Okay, cool.
Right?
I don't know. I wasn't there. But recreational fishers are allowed to catch a total of H fish during the fishing season. As a consequence, the fish population changes from year to year according to this recurrence formula, where Pn is the number of fish in the lagoon at the end of the nth year. If the initial population is P0, use induction to prove that this is the case. So do you all feel like you can do this one, or should I do this one as well? Yeah, let's do it. So let's do part 1. So part 1 is very, very routine, hopefully, by this point, right? So you're trying to use the initial population as P0, use mathematical induction to prove this. So first we're going to prove P1. So P1 is going to be equal to R, P0 minus H, which if you just plug in, P0 is just P0. So it's going to be R to the power of 1, so that's 1, that's fine. H, and then if you put in an R, but if you put this to the power of 1, then all of this will cross out, and then you're there. So you're good for P1. All right, so this is the k equals 1 case. I'm going to be quite lazy. N equals 1 case, sorry. So that proves that just fine. For the n equals k case, you assume it. I think you have all done that enough times that I don't need to repeat that for you, right? But I'm just required to prove n equals k plus 1. That's what you want from me, yes? So what we're going to do here is we're going to say p n plus 1 is going to equal, k plus 1 is going to equal r to the k plus 1 P0 minus H r to the k plus 1 minus 1 all over r minus 1. Cool? Alright, now, I know pk, so I'm also gonna just write it out just so that we have it, because we're obviously gonna need to use it. So pk is equal to this. Yep. So I know that this is the case. Alright. The other thing I know for sure is true is I know that pk plus 1 equals rpk minus h. Okay? So I need to prove that this is true. Okay? And I'm given this and I'm given this. Do you all see that? So how am I going to do that? I'm just going to sub it in, aren't I? I'm just going to sub it in and I'm going to simplify that fool, right? I'm going to make them simple. Alright, so I'm going to just say, alright, let's duplicate this, send this guy away, and then copy this whole thing and paste it. Cool? Everyone sees what I did there? And then I'm going to expand. That's it. All I'm going to do is just expand it, and we're going to be basically done in a few steps. So it's quite straightforward. This is going to be r to the k plus 1, p0. Yep. And this is going to be minus. Now, this is where it's going to have to be a little cheeky. I'm going to have to be cheeky. I'm going to pull out a h as a common factor, because both of these guys have a h, and then I'm going to need to prove that r times r to the k minus 1 all over r minus 1 minus 1 is equal to that whole thing. Basically, this bit equals that is kind of the crux of the proof, right? I just need to prove that that is equal to that. Now, r minus 1 is a constant, so I'm going to send him away. I'm going to get him out of there. I don't care about him, right? So I'm going to pull you out of there. I'm going to just be careful with the algebra here.
Isn't it plus 1 in there?
Is it?
Because you took like the negative couch.
Oh, yeah, sorry. Plus 1 inside the bracket. Yeah, you're right. Okay, everyone's happy with that? So then I'm going to pull out the r minus 1 at the bottom. I'm going to pull him out. Goodbye. And then I can turn this guy into r minus 1, if that's going to be the case. So this is going to be r minus 1. Yep. And then while I'm at it, I might as well expand those brackets, shall I? So I'm going to go r plus k. Okay. Yep, seems good to me. Now, I need to prove that this is all equal to r to the power of k plus 1, don't I? Minus 1. I don't see that working out. Something's going to go wrong here.
You get
No, I don't think so.
r to k plus 1 minus r plus r. Those r's will cancel out.
Ah, you're 100% right. Cool. Easy enough. So that guy and that guy go bye-bye, and then I'm done. Everyone happy with that? You didn't like it?
I see where I messed up.
Where'd you fuck up? So this is more important. More important than watching me do the solution. Let's figure out where we all screwed up. So where did you screw up?
When I took out the minus h, I remember doing it in the exam and had a plus and a minus. That was like a weird.
So you just screwed up on the thing that she corrected me on, yeah?
Yeah.
Okay. How do we avoid this in the future? Now, sometimes these are the most important ones to fix the silly mistakes. Now, when you're rushing through like this, oops, sorry, silly mistakes come up all the time. So what can we do to avoid silly mistakes? What can we do?
Add an extra step.
Yeah, add an extra step. Just literally add an extra step. That is fine. Or alternatively, my preference is not to add an extra step, because that's annoying. It means more writing. But my preference is to just take out the part that I'm working on and work on it on the side. That's much nicer. You're much less likely to screw that up. Do you kind of see that? So effectively what I'd like to do is, if I know I don't want to be writing a whole bunch of crap out, get into especially while you're practicing, now that you're doing lots of papers, get in habits of substituting, right? So what you'll do is I'll just write out, okay, I'm trying to prove that minus r times h, and I can actually pull this all out, pull out everything that I'm not interested in, and then just write it off to the side so I don't screw up anything. So I'm required to prove or show that r to the k minus 1 plus 1, yeah, times r minus 1. Simplify that. I might just simplify that on the side, right? So that way, I can't really screw that up because I can always check it here. With induction, it's really easy though, because you know that as long as you're following the rules, it's never going to screw up. So if after you've done enough inductions, there's really no excuse to be losing any marks on induction. You should pretty much never lose marks on induction. You should get it right pretty much every time. right? So that's something. I mean, you don't need to be upset at yourself. It's okay to screw up, but if you don't learn from it, then that's a bit stupid. Is that cool? And then hence show that if the fish population increases from year to year, then what? So this is actually the easiest part. I'm not even going to waste too much of my time on this. What can we say is going to happen if the fish population is going to increase from year to year? What can we immediately say?
dPn on dn is greater than 0.
dPn, sorry?
Like you differentiate population with respect to time is greater than 0.
You can do that, yeah, but I mean, you don't need to do that. That's complicated. So yeah, that's true. So again, let's think about all the different ways we could use, right? So the first way is you could, the derivative of the population with respect to time, right, is greater than 0. That's one way, right? But isn't it just easier to just say that Pn plus 1 is greater than Pn? Yeah, which is equivalent to saying Pn plus 1 divided by Pn is greater than or equal to 1. That's one way. So that's another way to do it. So I'm always going to, before starting an extension 2 problem, please don't just launch in. That is what idiots do, right? It is also the same thing as saying Pn plus 1 minus Pn is greater than 0. Either one of those is okay. Do you kind of see that? So which of the approaches is going to be easiest? Just looking at the problem and looking at the format that I've got Pn in, which one is the easiest way to do it?
Minus maybe.
Hmm?
The minus one maybe.
Probably, but I mean, like look at this one over here. Like, see this one over here? I kind of got a nice relationship between them. Yeah. I would say that the minus one is good because I've got this term over here, which is like a constant, and then I've got this term over here, which is also kind of pretty close to a constant. Yeah. So yeah, I'm gonna think that this one is probably gonna be my bet. If I'm a betting man, I'm gonna do it this way. That makes sense? You could do this one too. Like you could do this one too. I'm pretty sure this will work as well. It's just gonna be more work. So before starting, look at the problem, look at the form you've got it in, and then decide what you're gonna do. Okie dokie? So therefore, let's write that out. I'm gonna just use another color, right? Let's say Pn plus 1 minus Pn. That's gonna be the same thing as r to the n, and I'm also going to be cheeky as well. Like I've learned all these little tricks for myself. Instead of ever writing r to the n plus 1, I'm always going to write r to the n times r, right? Because that's the same thing, and I know I'm going to be subbing it out eventually anyway, so I might as well write it like that. Times p0 minus h, and then same thing here. When I have constants, I like to write them out the front here. Things that are not going to affect the proof, I'm going to write them out the front, and then write everything else out like this. R to the n times r minus 1. Feel cool with that? And then I'm going to subtract off r to the n, p0, yep, plus, be careful with that, careful, although I'm on to be talking, right? R minus 1, I to the n minus 1. Is that cool? Yep, so this is all greater than or equal to 0. Yep, this should all be greater than 0. We know that that's going to be equal to 0, greater than or equal to 0. Yep, so then what are we going to do? We're going to simplify, right? So we're going to try to simplify as much as we can. So we're going to take out some common factors here. Yeah? What can we do here? I'm just wondering, is there an even easier way to do this? Is there an easier way? Do we have any more information in here that we could have used? Pn, like, could we have used that? I'm just wondering, like, could we have used that somehow as well to make our life a little bit easier? I'm just wondering. I feel like there's a really, really easy way here. Because, like, when I'm looking at this and when I'm looking at this, they seem like very, very close, right? So I've got h. If I move this to this side, and then I've got r to the pn minus that is the same thing, right? So one way that actually might make this easier is I'm just thinking h is the same thing as r to the pn minus 1 plus pn. Do you all agree with that? Yeah, so that's the same thing. So then what I can do is I could probably sub straight into that and then show that it's less than there. I think, no, I think this is probably the way. Let's keep going. I just want to like look at it before I just launch into doing a bunch of algebra, yeah? What do we do here? So if I take an r to the n out of, all right, let's try it. Let's just try it without too much. If I factor out an r to the n times p naughts, yep, I'm going to end up with r minus 1. Yep, that's from this term and this term. If I take out a minus h on r minus 1, I'm going to end up with an r to the n times r minus 1 minus r to the n plus 1. These guys will go away. Yep. And what am I left with there? I'm left with r to the n, factor out an r to the n, h r to the n on r minus 1 outside of r minus 1. Everyone's in agreement with that? Minus all that. Yeah? And we know that this is all, we want to show that this is all greater than 0. Right? I'm just trying to prove that this is greater than 0. That's all I really need to show here. So if I was to pull out an r to the n outside of r minus 1, what am I left with? I'm left with p naughts minus h all on r minus 1. Do you all agree with that? Now, this part is obviously greater than 0. Yep. You'll see that. So I've just like done all of this part. So all I really need to do is just show that bit. See, this bit is kind of what can you all see that? That part is pretty much right there. So if I just make that equal to 0. Yep. So I want this to be greater than 0. So therefore I've got p naught is greater than h on r minus 1. Yep. Move that to the other side. I'm done. Cool. So you just kind of have to like trust your intuition and just follow it through sometimes. I think that's one of the things about extension 2 you kind of get a bit used to. It's kind of a bit like a trust fall a lot of the time. Like you just need to like know that you started with a sound principle and then just go through the algebra, and it should work out for you pretty much every time. Do you all sort of see that? Now, I'm not sure if that was the easiest way. See, sometimes if you go for this, it might actually end up being easier. I'm going to look at the solution. I didn't look at the solution, but let's what do they do?
Seban,
Yeah, go ahead. Yes.
how did you know to start with the p of n plus 1 is greater than p of n? Like, how did you get that from just that equation they gave you?
Oh yeah, so they did exactly what I did. They did pretty much step for step exactly what I did. So yeah, the question is, how did I know to do this, right? Look at what I did right here. It's asking me, show that if the population increases. All I've really been told is that the population increases. Yeah? So for the population to be increasing, yeah, the next year has to be bigger than the previous year. That's the most important thing that I've been given. Yeah? So if I don't include that in the proof somewhere, I'm not going to get to this result. I'm not going to get here. Do you all see that? Like, I'm not going to get there because simply I haven't used the information that they've been telling me. Is that cool? So there's really two ways to do it. Like George, you were saying you could do it with the derivative with respect to time. Why did I immediately say, hey, let's not do it that way? What made me say let's not do it that way? What do you think it was?
You could differentiate a long expression.
No? So I just like sort of went like, no, don't do it that way. Why, I want to now sort of address, like you said that, it seems like a good approach. Why did I say don't do that?
No t.
There's no t. There's no dependence on time. Do you all see that? So there's no t in any of these equations. So like, how am I going to differentiate this with respect to time?
And
Yeah, and so differentiating with respect to n is hard as well, because then you're assuming that a discrete variable is continuous. Do you kind of see that? So if you look at this one, differentiating this with respect to n, what would have happened if I had differentiated this with respect to n? Remember, you're saying with respect to n, not r. So how do you differentiate like 2 to the, like, derivative of 2 to the x? That's an exponential, isn't it? What's this equal to?
it's like a one thing.
Yeah, so
I
it's
can't remember the exam if I did it with all and
it's ln 2 times 2 to the power of x. That's what you're going to get there. So yeah, so you're saying differentiate with respect to n and assume that it's greater than 0. Does that make some sense? That is actually a perfectly okay approach. You can do that, no problem. But what you are doing, the only problem is that the problem with this, and if this went to a senior marker, he's almost certainly taking marks away from you. You'd only get a 1 because you're assuming that n is continuous. Do you see that? That's actually the real big problem. You're assuming that n is continuous. But then this is, of course, only true for n equals things in 1, 2, 3, etc. Right? Would this be true for n equals 2.5? No. Right? So when you differentiate, you're assuming that you're dealing with a continuous variable. Do you all see what I'm saying? So every time you use a derivative, I'm immediately going to be like, that's probably not the right thing to do because I'm dealing with something that's continuous here. It doesn't mean that you can't do it, but it's not you know, you can say, okay, assume that it's like continuous along that I basically assume that this holds for everything, but the whole idea is that n is an integer, and for derivatives, for d on dx, you need, for d on dn, you actually need n to be a real number. Do you all kind of understand that? That's why I said immediately, let's not do that. Do you sort of see that? Then what I needed to realize, okay, if something's going to be increasing year over year, what's the usual way to do that with a series? It's just assume that the next term is bigger than the last term. That's generally how we would go about that. Everyone's on the same page there? And then a bit of a trust fall. The two ways you could have done it would have been subtract them or divide them. That's really going to be the two ways. This is useful lots of times, by the way. The only reason I chose not to do this is because I saw that we're subtracting things, and it's probably easier to add things than to subtract things. Sorry, it's easier to add things than to subtract things, than to divide things, sorry, when you're dealing with multiple terms. Do you all follow what I'm saying there? So again, what did we learn? What are the main sort of takeaways here? Number one, only differentiate with discrete variables, right? Differentiate with discrete variables. So with discrete only. Oh, sorry, with continuous variables only. So that's going to be number one. Are you all happy with that? So I'm only going to want to differentiate if I've got continuous variables. And then the other thing is that if a series is increasing, right? If a series is increasing, what do we generally want to do? We want to use term n plus 1 is greater than term n, which can be expressed in one of two ways. Basically, term n plus 1 divided by term n is greater than or equal to 1, or term n plus 1 minus term n is greater than 0. And then you just have to choose the one that you want, right? A lot of the time, this is what extension 2 is going to be doing. They're going to be testing your ability to sort of do things. And sometimes, just, you saw me kind of stop there a few times while I was doing it. The idea is that sometimes the answer is just kind of to shut up and calculate, right? Sometimes that's kind of what you just need to do, all right? That's kind of going to be the case. Are we all clear with this? So, yeah, go ahead.
How can we access these notes?
Take screenshots while I'm doing it, I think. Sorry, I can probably upload them for you somewhere. But
Are you recording all these lessons?
yeah, they're all recorded.
Okay, yeah, then I can just go through the recording. It's okay.
Yeah, that's fine. So here's another one. This is a question 8. Now these, when you see a question 8, like these old sort of question 8 type problems, these are, so when I did the HC, the last question was question 8, and the average mark across the state was like, it was like 0.001 or something. Like basically no one would do question 8. It was I remember most of the Asian tutoring places would be like, just don't try it. Like they'd tell their kids, just don't attempt that question, try to get full marks on the rest of the paper. So yeah, a lot of the time when you see these questions, a lot of them are actually quite difficult. So just forewarning you, some of these are quite hard. Okay, so what are we going to do here? Let a, b, and c be positive integers. Prove that it's impossible for all three numbers to be perfect squares. But geez, how am I going to do that, right? So let a, b, and c. This is, these questions are going to be pretty hard because they're not going to give you a lot of information to start, right? So how are we going to start? What are we going to do? So we want all three of these numbers to be perfect squares, meaning that we require a, b, and c to be greater than 0. They're all greater than 0. Prove that it's impossible for all three numbers, a squared plus b plus c, b squared plus a plus c, and c squared plus a plus b to be perfect squares at the same time. Okay? So what does it mean for something to be a perfect square?
Squared integer.
Yeah, so it's you can write it as a squared integer of some kind, right? So basically, let's be let's call it p q r squared, right? Now, generally, when you get given a problem like this, the best way to usually approach it, because how the hell are you even going to start, is going to be a proof by contradiction. Okay, you're going to try to prove it by contradiction somehow. Is that cool? So when I say squares and I'm thinking proof by contradiction, I'm going to try to prove that something negative is going to be something that is definitely positive should be negative. Is that kind of cool? And so I have a few tools at my disposal. If I know that A, B, and C are greater than 0, the tools I have at my disposal, we're always going to sort of think about those. What tools do I have? So we have the AMGM. Yeah, we always have AMGM. So that A, let's call it M plus N squared, or sorry, M plus N on 2 must be greater than or equal to M times N square rooted. We always know that that's going to be true, yes? So that always has to be true, correct? That's probably not a bad bet because we're dealing with perfect squares, right? So that's probably not going to be a bad bet. The other one is the triangle inequality, that if A plus B is greater than C, yeah? So for any triangle, anything that forms a triangle, A plus B has to be greater than or equal to C. Is that cool? So we know that those are the two. Most of the time I'm going to go with AMGM, especially when I'm dealing with things like squares. The other tool in your tool belt is by contradiction. Right, contradiction. Those are really the contradiction, or you can also do a direct proof. Okay? With direct proofs, I usually am not going to have a direct proof when you're proving something is impossible. Proving that something is impossible, that kind of, that just yells contradiction at me, right? So proving that something is possible, that's usually a direct proof. Proving that something is impossible, usually not something I'm going to do with a direct proof. Is that cool? So just before I start, I'm going to sort of think of all the tools that are available to me, and I'm going to choose one. So I'm thinking AMGM looks like the bet, like the go here, right? So what I'm going to say is I'm going to say, okay, I'm going to assume they can be expressed as perfect squared. Can be. Okay, so assuming that they can be expressed as perfect squares, these three things must be true. Do you all agree with that? For some P, Q, and R, where P, Q, and R are integers. P, Q, and R are integers. Do you all agree with that? Any problems with that? Or are we happy with that? All right, so what are we going to do now? What can we do? So I'm thinking AMGM might be the go. What are we gonna do with this? So can we say that, all right, a squared plus B plus C, let's say plus B squared plus A plus C, yeah? All on 2 is greater than or equal to the product of the two. So it's going to be greater than or equal to some P squared times Q squared. Is that cool? It must be possible to write it that way, right? It must be greater than or equal to some squared value. Right? That's kind of where my brain initially goes. What can we do beyond this? Now, what I'm going to start with is if I know that I'm dealing with something that can be written as a perfect square, what else can we do to simplify this? I feel like we need some insight here. We haven't got an insight. So like with this, before starting a problem, I'm not going to jump in and do a whole bunch of calculations before I've got a good insight. I'm not really seeing how this is going to help me out. Does anyone have any ideas about this when we're starting it? When you see a problem like this, where does your brain first go?
Could you group the A's and then like add 1 minus 1 and then do like A plus 1 all squared?
I'm just looking just before I start if we've understood the understood the problem properly just before I start. Are we looking at question? We're looking at question. Which question are we looking at? Did you post a solution for this? Question
Let me check.
8A. I don't think you have. Because I just figured let's just take a look at the solution because I feel like this one's this is one of those like really vague ones where in order to even start you kind of need to have some kind of insight, and I'm not seeing a quick one, and it's not worth wasting a whole bunch of time unless we have some insight here. Does anyone have any ideas at all about where we might start, or not really so much? Like if you saw this in an exam, where would you begin? Well, what insights do you kind of have? Yeah. That's a reasonable one. Yeah, like I said, these questions 8, this one I'm pretty sure this is old syllabus. These ones, again, most of the state pretty much wouldn't touch it. I think, but most of the students I taught ended up doing most of them. Like I think like my average marks would be like around 12 for most of my students. So most of them could get this by the end of the HC. But the most important thing I would say is before starting a hard question like this, you need some kind of insight. Otherwise, you're just going to be like floundering around just writing random shit. That's not usually useful. Oh, you've got the solution?
Yeah, I posted the solution.
So what are they doing here? They're saying, okay, so they use triangle inequality or something? Okay, can't be perfect squares. C squared is less than C squared, A squared plus B squared, which is less than C squared plus 2C squared, which is less than C squared plus 1 squared. That makes no sense to me, eh? I have no idea what that solution says. I'm not sure what they did there. C squared is less than A squared plus B squared. Oh, okay, so what they did, alright, so what they did, this is silly, but that's funny. But okay, what they did is they assumed, they used the proof by contradiction. Okay, so they did use a proof by contradiction, but it's actually not, that's quite clever what they did. So let me show you what they did. I can walk you through it, but it's like one of those things where you just have to you have to come up with a contradiction really, really well. So they assumed, what they did is they assumed that A is less than B is less than C. Is that cool? So they've just chosen, they've said, okay, you could pick any three numbers you want, and then we're just going to assume that A is going to be the smallest of the three, B is going to be the next one, and then C is going to be the other one. So they're making like a very strong assumption here, right? So then what they then did is that they just said, okay, B squared plus A plus C. Now, since you know that A is less than B is less than C, C is the biggest of these numbers. So let's do it specifically for C, right? Let's do it for C. Let's do the C squared example. So we've got C squared plus A plus B, right? Since C is the biggest of those numbers, then I know that replacing A for C and replacing B for C would make it C squared again, right? So C squared plus C squared. Is that cool? So it is going to be less than C squared plus C squared. But they're also, because they're saying that it's greater than or equal to 0, and they've also said they're integers, right? They did say that they're integers, didn't they? Yeah, they're positive integers. So what they did is they just said, prove that this is, so they went a little bit cheeky. So they said this is less than C plus C. Do you all get that? That's what they're doing. Because A is less than C, and B is also less than C. Do you get that? That's what they did, right? And so then they went, okay, so that means it's less than or equal to, and this is where they pull out the magic, which they often do sometimes. This must be, what's even bigger than that is C squared plus C squared, C plus C plus C plus 1. Okay? Why they're doing this is they're saying, okay, C squared plus A plus B is less than C plus 1 squared. Do you all see that? So the point is that this number can't have been a perfect square because this is a perfect square. You see that? That's a perfect square. So if that one's not a perfect square, then what's the argument there? C plus A plus B can't be a perfect square.
I think it's because it's greater than C squared, so it's between C and C plus 1 squared.
Mm-hmm.
So like C plus 1.
Oh, true. You've actually got a very good point there. Yes, that's right. Very good point. So yeah, it's sandwiched between C and C plus 1 squared. So they actually use this thing called the squeeze theorem for this. That's cool. Have you guys learned about the squeeze theorem? Has he told you about the squeeze theorem? Basically, it's like the idea that if you sandwich it between two values that are right around each other. It's fucking hot in here today. Eh? Let's see if I can turn on the air conditioner. Just 1 second. It's gonna get pretty hot in here. 1 second. Can you see if the windows are open? Is the air conditioner? Very nice. Is the air conditioner working?
But I think that
Who thinks
balance is
it's-
Charles.
Huh?
What balance is Charles, right?
Who thinks of this?
You.
Who assumes that? Who assumes that? Doesn't include assume. I'll use 5 languages as an example. And then we'll probably move on to the next question and why I'm sorry.
Did you say we're getting extension ones now?
You guys find extension 1 harder than extension
Are they both
2?
open? Both windows are open?
They're both fine. I think it's way worse than extension.
Wow.
Extension
But I needed to do better than extension 1, bro. Shit.
I'll figure it out.
She fumbled my extension 1, right?
When you're done, just give me a call. We'll sort it out.
Extension 2.
Alright.
Is extension one up?
Alright, so
Extension one is kind of easy, man. Very, very easy. And so bad extension one.
So basically, what we're trying to say here is that this number and this number are consecutive. They're consecutive square numbers. See these two? These two are consecutive square numbers. Square numbers. So this number cannot be a square number because there can't be another number in between the two consecutive square numbers. That's basically the argument that they're doing. And they're saying do the same thing for A and do the same thing for B. That's basically the idea. Okay, so basically there's that one will be used to prove A, and that one will be used to prove B. Right? So that's basically the idea. It's yeah, you basically needed that insight. The proofs are usually pretty straightforward, but you needed an insight. So a lot of these ones you just didn't touch unless you saw it. Kind of was the way these ones went. So yeah, unfortunately there are some questions like this, but you just as you practice them. One of the good things is that once you've done a lot of practice, you would have probably seen this before because these questions are just kind of recycled, rinsed, and repeated most of the time. So when I went into my HSC by this time, like after I'd done like maybe I think did 30 or so papers for extension 2, something like that. So by that point I'd kind of seen every question. So there were very few questions that I hadn't seen before, and like this is a pretty standard question you see reasonably often. Okay, so that's the best thing I can say there. We don't have any more questions that were asked. So we've done all the ones that have been posted. So what I might do then is we might just continue looking through the locus stuff we were looking at last week. Yeah, because we were looking at the locus problems last week, so we might just continue there. So I'll just bring those up. So everyone found okay with everything today. So I think as you practice this week, find more questions. Generally, the kinds of questions that are best to bring up in class, as I said, are not questions that you just find like completely evil. It's more useful when you find a question you think, gee, there's probably an easier way. That's kind of where you're going to get the most bang for your buck here, as I said. So let's look at the 4-unit paper again. The 4-unit one. Which chapter was it again? Do you remember? Anyone? It was like locus. I think it was like the 6th chapter or something. 4th chapter, 3rd chapter. No, locus problems were the 1st chapter, weren't they? 1F. Okay. So we'll look at a few more of them just because we only got like a very short amount of time last week, and I think we're probably only going to get a short amount of time this week, but that's okay. So we're going to look at 1F again. Shit. Okay. One F. Let's look here and try to work this out. All right. So last week we looked at these examples, right? So we looked at these ones over here. So what we're gonna look at some more. Any others that you kind of found difficult? So we all learned how to do those ones. I'm gonna do some like these straight line ones as well, because I think these ones are interesting to see, and the geometry is actually pretty easy as well. So we'll look at the geometry of these ones. So look at those two. Okay, so I'll just do that. Look at the geometry of some of these. All right, so let's do this. So let's say that we're asking you to draw the locus of something like this, right? What's the general way of doing this? So I've got this point 2z and then 2 minus I. So let's pick our little complex plane here, just the same way. And I'm going to write the point z minus 2 plus I. Okay? Is less than or equal to some constant. Let's just do equal to some constant for now, and then we'll deal the less than case in just a minute, right? So 2 plus I is going to be, 2 minus I. My bad. Yep, 2 minus I like that. Yeah. So you're going to pick 2 minus I. That's going to be 2 minus I right there. Okie dokie. And then you want the distance from this point to be equal to 2. Yeah. What does that look like, right? So the distance from this point equal to 2. That's a very, very easy locus. What does that one look like? It's just going to be a circle, right? So you're just going to say, okay, find all the points for me that are exactly 2 units away. So it's going to basically line up with this point over here. So you can just draw the 4 corner points if you like, and then realize that it just makes a big circle like this. If it's less than, it's like this. So this is kind of one common locus point, right? Now to prove that it's a circle, if you wanted to, like if you got stuck on this and you're like, I'm screwed in the exam, just like always, you can always rewrite this as x minus iy minus 2 plus I. Yeah? Magnitude is equal to 2, right? One of the tricks you can use to really help with this one, by the way, is you can always square both sides. So if you square both sides, makes it a lot simpler to find this, right? Anytime you're dealing with these, I generally recommend that you square them if you're going to be doing it. So this is geometrically, but you know sometimes you'll forget how to do it geometrically, and that's okay. So another way is algebraically. Okay, so then what you're going to do is you're going to go, okay, x minus 2 minus, let's say plus I, let's say 1 minus y squared equals 2, and you're gonna square that, and that's gonna equal 2. Now, one of the cool things about this is, remember, the absolute value of z squared is equal to z conjugate, and that actually makes expanding these very, very easy, right? Because these terms always turn into a difference of two squares. So if you did that, this whole bit would just turn to x minus 2 plus iy plus I, let's say 1 minus y, and then you multiply that by x minus 2 minus I 1 minus y. Yep, and that's going to equal 4. Yep, and so if you expand that out, you get x minus 2 all squared minus I 1 minus y. I squared is minus 1, so that goes away, turning into a plus, and then that's going to be squared as well. Does everyone follow that? Any problems? And that's going to equal 4. And that's it. I'm kind of done there. I can pull out a minus sign from this guy. Write this as x minus 2 squared, and write this as y minus 1 squared. I think we've made a boo-boo here, haven't we? So this should be a plus, right? So did we expand that out wrong or something? Oh, that should... Yeah, I don't know why I did that. Okay, so that's plus, 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 plus. Everyone follows? So that's kind of how we algebraically do these. So you can always do them geometrically or algebraically. If you're ever screwed, you can always do them that way. That's kind of one of them. Now, I'm interested in these ones as well, because these ones are another type, right? So this is another type of locus that you often see. So let's do this. So if I do z plus 1, I'm going to give you a sort of hard one if I can. So let's suppose I asked you to find z minus 1 plus I equals z, bless you, plus 2 minus 3i. Yep. What is this one going to look like? So let's draw the plane this time. Does anyone know what this one looks like?
Is it a straight line?
Yeah, it is going to be a straight line. Do you know how to find the straight line? Yep, so we're going to rewrite it as, well, we'll try it. We'll try to do it. So we'll say geometrically. Let's try to do it geometrically. Minus 1 minus I. Yep. Equals z minus 2 plus 3i. Yep. So, and again, just in case you forgot this one, I just want to sort of go back here just for a moment and just remember this. Z minus something, I'm saying I'm picking some point z. Let's say that this is my point z. Yeah? What am I saying? I'm saying this is the point z, and this is the point 2 minus I. Z minus this complex number is what? It's the vector that's like ends here and starts here. Final minus initial, like we said, right? So this is the vector that represents the inside of this modulus. Do you all agree with that? Let's call this point C, just to make my life easy. Z minus C is this complex number. This complex number is Z minus C. I'm saying the length of Z minus C should always be 2. I'm finding all the points where it's equal to 2. Do you all see that? That's geometrically what I'm saying. This is Z, this is C, and this is Z minus C. And I'm saying, can you show me all the points where its length is exactly equal to 2? Do you all follow how that would work? Yeah? So then this one is asking the same problem. I'm saying, okay, let me pick the point 1 minus I, so it's going to be 1 minus I is going to be 1 minus I is like right here.
Shouldn't it be a negative 2 inside the bracket?
Yes, it should. Quite sloppy with that. So negative 2 plus 3i, so negative 2 plus 3i is going to be over here. Yep. So negative 2 plus 3i is right here, and this is 1 minus I is over here. Do you all follow that? Now, what I'm saying is let's pick a random point z. I'm going to pick a random point z where its distance, so this one is z minus the constant, so this is my random point z. So this is z minus the constant, so this is z minus 1 minus I. That's what that one looks like, yeah? And this is the second point over here. I'm saying this is z minus 2 plus 3i. That's what that one looks like, right? It's final minus initial. That's what I'm trying to say. What am I saying? I'm saying that the lengths are exactly the same. The lengths of those two blue vectors are exactly the same. Where might that happen? Well, the most obvious place where that's going to happen is along the line joining them, right? If you take the line joining them and you find the midpoint, that's going to be one of them, right? That's going to be an obvious point where this z is obviously going to have that value, right? And then, okay, if I want to keep the length the same all the time, I have to go up this line, or down this line, and that's going to keep the length the same, right? Because if I went this way at all, right, I'd be making this one shorter, yeah? I'd be making this one shorter and making this one longer, which is no good, right? So what I need to do is I need to go perpendicularly so that if I make this one longer, I make this one longer by the exact same amount. Do you get that? So the locus looks like, well, it's going to look like this line over here.
That's us to sketch that we need the midpoint.
You agree with that? So this over here would be the midpoint. The midpoint right here would be, I don't know, but usually, generally speaking, the easiest way to do it is find the x and y intercepts of this point, right? So you could find the x and y intercepts of this line. Okay, that's kind of what you would do. Everyone knows how to do that, right? So once you know the midpoint, could you easily enough find it, or not so easily? So if you found this complex number joining these two, if you rotated it by I, it would point that way. Do you all get that? And then using that, if you knew the midpoint, then you could sort of go up and down to hit the things. Do you want me to show you how to do that? Or yeah, you want me to show you how to do it? Okay, cool. So then, what's the complex number joining these 2 points? What is it? I'm going to subtract this. This remember is the point minus 2 plus 3i, and this is the point 1 minus I. So the midpoint is going to be, well, it's going to be minus 2 plus 1, so it's the average of those. So minus 2 plus 1, so it's going to be minus half. Yeah. And then 3 minus 1, which is going to be minus 2, so minus half I. Is that right? Or minus I? Minus half minus I. Everyone agrees with that? Because I don't. Plus I. That's yeah. Minus half plus I. Everyone's happy with that? So that's going to be the complex number. That's going to be the midpoint, right? Now the complex number that joins them, so that joins the two of them. Let me just kind of show it here, right? This complex number is which one? What is it?
Minus 2 plus 3i minus 1 minus 2.
Yeah. So minus 2 plus 3i minus 1, so that's minus 3. 3i minus I, so it's plus 2i. Everyone agrees with that? Now, if I wanted to rotate it, so that would be, to make a point this way, what would it be? It would become 2i, or I times I is minus 1, so it's going to become minus 2 minus 3i. Everyone agrees with that? That's going to be that vector over there. Yes? Everyone got that? Now, usually when I'm solving these, I just do them with vector math. It's just easier that way, right? So at this point, I've got the two complex numbers I'm interested in. To find the x and y intercepts, I'm just going to use vector math. So I'm going to say, okay, the x component is minus half, and then 1. Yep, and then I'm going to say take some constant, so I'm going to scale up. So I'm going to start here, and then I'm going to take this vector and I'm going to scale it up by some constant to see where I reach. Okay, so minus 2, minus 1. Yep, is that cool? So this is the vector that I'm dealing with, yeah? So, and then that's going to be equal to all the points along my line. This is basically the equation of my line. Do you all agree with that?
Why is it minus 2 minus 1?
Minus 2 minus 3. My bad. I don't know why I wrote it 1. Minus 2 minus 3. Do you all see it? So let's just put this all in Desmos so this all we can see it all, because you do want to be able to visualize. Now again, if you go into complex mode, just making sure that we haven't screwed this up. So let's show the answer. Minus z minus 1 minus I equals, I'll just write it out in its original form, z minus 1 plus I equals the absolute value of z plus 2 minus 3i. It hates it. We only support implicit equations of x and y. Okay, sure, I can write that as x plus iy for you, Desmos, you bastard. X plus iy. There you go. Okay, so it looks like looks like that. And the first point should be at minus 2 plus 3 I, and the second point should be at 1 minus I. So it looks like, does that look like the midpoint to you, roughly? Yeah, and we said that the exact midpoint should be minus half plus 1, plus I. Yeah, looks good to me. You all happy with that? So that's what we've got. Then the other thing we're saying is that the vector equation is going to be minus half 1 plus some constant times minus 2 minus 3, right? And then as I slide around that constant, it should be on the line. So that's, hold on, why did I say minus 2 minus 3? Minus 2 2i squared is minus 2 and then minus 3i. So I've got the direction wrong here. Why is the direction wrong here? Because what's this vector minus this vector? Can someone help me out? This vector minus this vector, what are they again? I'm going to double check that. Minus 2 minus 1, that's minus 3. Yes? And then minus 3, then 3 minus minus 1 is 4. So that's actually a minus 4. Got it? Now we're good. See that? That's my vector equation. Yeah? Now you have two choices here. You can either convert, if you want to, you can either convert that into a xy equation. That's okay. Or you can just work with the vector equation directly. If I wanted to get to 0, I'm just going to let the x part be 0. Do you all kind of see that? So that's going to happen when k equals what? Well, if this part is 0, you got minus 4k. You're effectively solving for, head out of the way. You're effectively solving minus 4k minus half equals 0. Yeah? Cool. So that's the same thing as just putting the half to that side with a minus sign and then putting the 4, so k equals 2. Yeah? K equals minus 2. Everyone sees that? So if I plug in k equals minus 2, it should be right on the... I screwed that up. Something's wrong. So it should be... Yep, do you all kind of... So, wait, something's wrong here. So minus half, yep, minus 4k. That's the x part, right? And I want that to be equal to 0. Yeah? So then if I solve this, if I move this to the other side, this becomes positive half. And then dividing by both, I get it 1 on 8. No, minus 1 on 8. Sorry, that's what I was after. K is minus 1 on 8. Everyone follows that? So plugging that in, minus 1 on 8. That puts it right on there. See it? Cool. And then you can do the same thing for the y. Everyone happy with that? So if you wanted to do it manually like that, you can do it that way too. But that's only if you want to like fully annotate the diagram. My preference is though that when you get this one, again, once you practice them all, you'll know which one to use when. Generally speaking, if they just want a general sketch, this is enough. You don't need to draw it super nicely. But this is how you do it geometrically. Geometrically. Last one is algebraically. Okay. Now, when you guys have a hour off, for those of you that have an hour off, feel free to like just go to Macca's or whatever you want to do. Like, don't you don't feel like you have to stay here. So take an actual break, come back, and then we'll continue. Right? So algebraically, what do? So we're going to do, again, this is going to be the same thing here, but I'm going to do x minus 1 plus I, y minus y plus 1, yep, equals x plus 2 plus I, y minus 3. Do you all see that? That's what we're doing. Again, just like always, I'm always going to square these. Because then I'm going to get to do the conjugate thing. So this just ends up being x minus 1 squared plus y plus 1. I'm going to skip the algebra a little bit. Plus y plus 1 squared. Oh, sorry, I got my thing sometimes freezes here. So sorry, 1 second. It's just frozen for a second. I think they just 1 sec. Okay, it just does this sometimes. Sorry, excusez-moi. Why are you frozen fool? Alright, that's cool. Yep, so you got okay, and then at that point you're just going to do some algebra. What's the quickest way to do this algebra? I want to see like how clever we can all be. What's the quickest way?
If you extend it, all the x squares and y squares comes out.
Yeah, but there's an even quicker way. Can you see it? Move this to the other side, what happens to it?
Difference of 2 squares.
Yeah, that's nicer. You'll see that? Cool. So what's that going to be? That's going to be x minus 1 minus x minus 2, x minus 1 plus x plus 2 equals y minus 3 minus y minus 1, y minus 3 plus y plus 1. Cool? How much easier is that, right? So just cross, cross, cross. So, I mean, it's not that much easier, but, you know, it's nice. And these guys just all cross out, and you've just got some constants. So you got minus 3 outside of 2x plus 1 equals minus 4 outside of 2y minus 2. Okay? So factoring out that guy, so you got 2x plus 1 equals 8 on 3 y minus 1. Okay, so this is probably the easier way in this case, right? It's actually probably easier to do this one algebraically than geometrically, and if you look carefully, this should still give you the exact same, line. So just looking at this, I'll just graph it here. 2x plus 1 equals 8 on 3 y minus 1. Look at that, same line, right? So exact same way to do it. So this is just how you do it, right? So you can always do it either of these ways. If you're screwed, algebraic is never really that hard, right? So when you guys are saying that it's difficult, it's like not really. You know what I'm saying? So you can kind of always do it this way. So do you guys feel a bit more comfortable with locus problems? I'll probably stop bringing them up now, and then on the next time when I see you guys, I'll start looking instead at the next problems you were saying, which I think were, which ones were they? Not prims and coms. Sorry, I'm just putting everything in the same book because the fire we do a lot. We're looking at complex numbers, but I think you guys were saying complex numbers in general. Is there another part of complex numbers you want to look at next time? Yeah, sure. You want to do that again? Yep. Oh, you were away for that. Were the rest of you guys okay with routine idea? Or should we do more on those? More